Looking at number 21 from the first semester final exam. Number 21 says expressed in simplest form. And the problem is 6 minus 12 over k, and that's all over 12 over k minus 3k. No problem. I'm going to write this out on the paper so that we can look at it and do it together. Okay? So the top says 6 minus 12 over k, and that's all over 12 over k minus 3k. To do these problems, it's a good idea to just break them into two separate parts. Let's just concentrate, first of all, on just the numerator. So everything above the pencil. Let's just simplify everything above the pencil first. So on the side over here, I'm going to do that. We're just simplifying this numerator part first. So 6 minus 12 over k. If I'm going to subtract these, I have to get a common denominator. To get a common denominator, I think a good way to do that is I'll take this k, and I'm going to multiply this 6 by k over k. Why can I do that? Well, what is k divided by k? K divided by k is 1. So I'm really multiplying this 6 by 1. 6 times 1 is 1. I'm going to change what it looks like maybe, but I don't change what it is. So k times 6 is 6k. It's now 6k over k, right? Because you see how those k's would cancel out and I'd get that 6? This is the same as that. It just looks different. 6k over k minus 12 over k. The nice thing now is that this has a common denominator, which means that we can actually combine things. So 6k minus 12. Well, those are not like terms, so we just write down 6k minus 12 here, and it's all over k. Well, we could factor this, but for now, let's leave it. We've found what is the denominator. We found the we found the numerator part of this. Okay, this is the numerator, the top part, the numerator. Now let's go back and try to simplify the denominator part. I'll do that right here on the bottom. So we have 12 over k minus 3k. How are we going to be able to get these to have a common denominator? Well, I see down here the denominator is a k, so how about if we multiply the top and the bottom by k here, right? This is like a 1. So we have, this is going to be 3k times k will give us 3k squared. This is over k, right? 3k squared over k. And this is 12, we're bringing this down, 12 over k minus 3k squared over k. Good. These denominators are the same now, and so we can actually combine things. So we get 12 minus 3k squared over k. This can be factored some, but for now we'll leave it. This is the denominator part. Well, you see, we simplified the numerator part, and we simplified the denominator part. So now we have this numerator part divided by this denominator part. Let's write that out. So here's the numerator part, right? That's 6k minus 12 over k. See, there we got that from right there. And now we're going to divide that by the denominator part. The denominator part is right here. That's 12 minus 3k squared over k. I'll write it out right here. So this is 12k minus 12 divided by 12 minus 3k squared. Right? Can we see that? 12 minus 3k squared over k. Good. Now, when you're dividing fractions, what can you do? Well, you have to change it into a multiplication and then multiply by the reciprocal, right? So this is going to be 6k minus 12 over k times, what is the reciprocal of this? Well, that's k over 12 minus 3k squared. So far, so good. Well, there's already something I can see to cancel out, but let's factor what we have here so that it's obvious what everything can be factored out. So a 6k minus 12. How can we factor that? Well, there's a greatest common factor of a 6. So this is, I'm going to pull out that 6. 6 times k minus 2 over k. That's what this is, right? This is the same as this. Times, here we have this k, and let's factor what we have down here. What can we pull out of this? Well, we can pull a 3 out of both of those terms. So this is 3. What times 3 gives us 12? Well, that's a 4. And then minus k squared. This 4 minus k squared, we're not done, because 4 minus k squared is a difference of 2 perfect squares. Be really careful here. See, this number comes first, so we have to write it that way when we factor. Okay, so I'm going to rewrite this. This is 6 times the quantity k minus 2 over k times k over, there's our 3, right? And now we're going to factor this 4 minus k squared. Okay, it's a difference of perfect squares, but the number comes first, so it's 2 plus k times 2 minus k, right? We're doing pretty well. And now we can look for opportunities to cancel out any common factors. Right, so we're going to cancel out some common factors here now. Well, this k and this k have been waiting to go. They can be canceled out. Now this k minus 2, down here, there isn't a k minus 2, but there is a 2 minus k. Remember, when you have this minus that over that minus this, that means you can cancel them out, but what was on top becomes a negative 1. Right? This actually becomes a negative 1. Let's multiply out what we have. So 6 times negative 1. Well, 6 times negative 1 is negative 6. Is there anything else on top? I don't see anything else on top. Over 3 times the quantity 2 plus k. So 2 plus k here, right? This can be simplified a little bit more, because what is negative 6 divided by 3? Negative 6 divided by 3 is negative 2. So we get negative 2 over 2 plus k. There's nothing wrong with leaving it in parentheses, or nothing wrong with leaving it as a 2 plus k. I'll just mention that most of the time when you have 2 plus k, usually that would be written as negative 2 over k plus 2, because addition is commutative. That means that the order doesn't matter. This is the way it would usually be written in a book. So there is our best answer for number 21.